Okay, so section 5.3, part 4. It's the last part of section 5.3. So it says star because I'm not letting you get credit for calculus without learning this. So you need to know how to graph functions by hand. So you need to know all the little things like horizontal asymptotes, vertical asymptotes, maxes and mins, concave up, concave down, intercepts. Yes, so your quiz will be over this. We're not going to finish this whole section, which will be fine because by the end of this you'll be like, okay, I'm good. We can do 2 examples and I'll be fine with that. So they take a long time. All right, so the guidelines for sketching a curve, it runs you through all the different things you would ever need to find. Okay, so domain for the first one. Is there anything that's making it undefined? No. So the domain is negative infinity to infinity. Vertical asymptotes, we don't have a denominator, so we're not going to set our denominator equal to 0, so vertical asymptotes are none. First derivative. Oh man. I'm going to do it over here. So I'm going to get 12x squared plus 36x plus 24. So that's my first derivative. Second derivative. I'm going to get 24x plus 36. Let's go ahead and find when each of those are equal to 0, so we can find when it's increasing and decreasing for our graph. So I have 0 equals, I'm going to pull out the common factor of 12. I have x squared plus 3x plus 2. So it factors into x plus 2 times x plus 1. So at x equals negative 2 and at x equals negative 1, I have some kind of critical value. So either a max, a min, or it's called a saddle point, like the x cubed. That's called a saddle point. All right. So I put f prime next to my number line so I know what I'm trying. So I'm plugging everything into f prime. So when I plug in negative 3, I have 12 times a negative number times a negative number, so I get a positive number. If I try negative 1.5, I have 12 times a positive number times a negative number, so it's negative. If I try 0, I get 12 times 2 times 1, so it's positive. So f prime is telling me where it's increasing and decreasing, so I'm going up, I'm going down, I'm going up. That should make sense to you because look at your original problem. 4x cubed was your first term. So it should look like x cubed. Okay, f double prime. So I want to find when it's equal to 0. So you get negative 1.5. Okay, you're checking your numbers in your second derivative. So when you check these numbers in your second derivative, you get, so you could pull out a negative, or you pull up 12 if you want. But if I try like negative 3, I'd have 24 times negative 3, so that's a big negative number, plus 36, it's still going to be negative. So negative 72 plus 36. All right, if I try 0, I get 0 plus 36, that's positive. Okay, so don't draw your arrows up and down on these ones because now you're talking about concavity. So it's concave down and concave up. I have no horizontal asymptote. It wasn't a rational function. It wasn't like a fraction. There was no denominator. Intercepts. I can find my y-intercept and my x-intercept. My y-intercept is real easy. It's when you plug in 0 for x. So in your original problem, if you plug in 0 for x, 8. So you get 0, 8. X-intercept's a little bit harder. It doesn't look like you can factor by grouping. So in ones like that you can't figure out by hand, I mean, you could do P and Q. I'm not going to make you do your rational roots theorem as well, though. So you guys can go ahead and plug this into your calculator. hard to tell on mine. Like my graph looks like it goes up and hits the axis maybe and then comes back down. So if you can't tell, go ahead and try to find that 0 or trace along it and see if you, well, let's find the 0. So let's get on the left of it and on the right of it. So -2, 0. And it does just hit it. All right, and then try the next one. So -1/2. Okay, one way that I could know that that just hits that point at -2, 0 and then comes back down is you can kind of count the zeros. So see how we only have 2 zeros? But based on our original function, how many zeros should we have? 3, because it's x cubed, so you should have 3. So that's why this goes up and hits and then comes back down. It has multiplicity 2. It's a 0 twice. Okay, so those are your zeros, so -2 and 1/2. And -1/2, right? Okay, so that's our sketch. So we're going to put all of this information in. So when you guys sketch this on your homework, I want everything labeled. You guys only have like 2 problems, so I wouldn't worry about it too much. Okay, so you have -2, -1/2, 0, 8, we want to know where the max and mins are. So we knew there was a max at -2, and we now know that point, f of -2 is 0, right? Because we just found -2, 0 was on our graph. What about f of -1? So go back to your original and plug in -1. If you have it in your table, it's going to be real easy. -2. We also want to find f of -1.5 because that's going to be a point of inflection. So that's -1. Uh-huh. Okay, so it comes up, it hits -2, 0, and that's a maximum. Then it comes down. It goes back up and hits oh wait, I guess I need to find that minimum. So the minimum is -1, -2. So that's right here. Then it goes up, hits that 0, goes all the way up to 0, 8, and then it keeps going up forever. Okay, so on your homework, I would want to see this labeled, so -2, 0, and that's a local max. I'd want to see -1, -2, that's a local min. I'd want to see your zeros. You can just list your zeros, actually. And then I want to see the point of inflection. So at -1.5, so right here, you get a point of inflection. So pi, point of inflection. So -1.5, -1. Okay, so I want to see the maxes, mins, and point of inflections labeled. And then as long as you have these written somewhere, I'll be fine with those. It's kind of hard to write all of it. Okay, so next one. Okay, so go ahead and find the first and second derivative. Think about the domain, the vertical asymptote. So I'll let you guys start this one, so see if you can do it. This is pretty much how your quiz is going to be. It's just going to be one question. You have to label everything. So try this one. Okay, so what'd you guys get for a domain? It has to skip over 0 because 0 is when it's undefined, right? Okay, the vertical asymptote is x equals 0. That's why it's undefined there. So you just set your denominator equal to 0. Your first derivative, these are going to be a little tricky. So low d high minus high d low, all over the square of what's below. Now, when you're taking the first derivative, sometimes it's nice if you can pull out what they have in common. Like, see how you have x squared, and you can pull out x squared from the first one as well. I mean, it's x cubed, but you can pull out x squared. So I'm going to pull out x squared to the front and see if that helps. Sometimes that makes it a little nicer. So if I pull out x squared, I'm going to have x and 2x left, so 2x squared. And then I'm going to have minus 3 times x squared minus 3 all over x cubed squared. In other words, x to the 6th. I guess I'll just write x to the 6th. Okay, so I get x squared times 2x minus 3x, so negative x squared. And then negative 3 times negative 3, so plus 9, all over x to the 6th. So x squared and x to the 6th reduced to x to the 4th. So you get 9 minus x squared all over x to the 4th. Oops, because I hit extend page. So your second derivative is low d high minus high d low all over the square of what's below. Okay, so again, let's use that trick. So I'm going to pull out x cubed. So when I do that, I have x and negative 2x, so negative 2x squared. I get minus 4, so minus 4 times 9 minus x squared. So I'm going to have minus 36 plus 4x squared all over x to the 8th. So I get x cubed and x to the 8th make x to the 5th. So 2x squared minus 36 all over x to the 5th. What did I do? It's positive. All right, so important points. These ones are easy to do in your head, so don't write all these steps out if you could do these in your head. Do you guys see the critical values? 0 is one of them. It's when it's undefined. And then what's going to make the numerator 0? 3 and negative 3, right? See them? All right, so then plug in. So if you plug in negative 4, on the top you're going to get a negative number. The bottom is always positive. So I'm going to have negative. Same if I plug in 4. Do you guys see it's symmetric? So if I plug in 4, I'd get a negative as well. If I plug in negative 2, I get positive on top. If I plug in 2, I get positive on top. And at 0, it's undefined. So if you want to do like a dotted line to remember that that's your vertical asymptote, sometimes that will help. So that was in f prime. F double prime. Not as easy to do in your head. You can pull out the 2, you get x squared minus 18. So it's negative square root of 18 and positive square root of 18, which does simplify to 3 root 2. If you want to use 3 root 2, you can. From setting the numerator equal to 0. And then the bottom would still be 0, which was our vertical asymptote. So if I plug in negative 1, on the top I'd get a negative number. On the bottom I get a negative number, so it's positive. If I plug in 1, I get negative on top, positive on bottom, so negative. If I plug in something bigger than square root of 18, so 5. If I plug in 5, I get positive on top, positive on bottom. And if I plug in negative 5, I get positive on top, negative on bottom, so negative. Okay, so let's draw our arrows for the f prime. So down, up, down. And our concave up, concave down for f double prime. So down, up, down, up. And then we sketch all of this. Okay, we're going to need to know what's f of negative 3, f of 3, f of negative square root of 18, and f of square root of 18 are. So the easiest thing to do is put it into your table. I mean, obviously on your non-calculator portion you would not be able to do those, but These are going to be like points like maxes and mins or points of inflection. So for the first derivative, you're going to have max and mins or saddle points, like I called it. Or you could have, for the second derivative, you could have points of inflection. So I have negative 0.2 repeating, so 2, 2, 2, and positive 0.2 repeating, and negative 1.96. Oh, no, negative 0.196. Do that all the time. Negative 0.196 and positive 0.196. Okay, so we sketch it. Oh, horizontal asymptote. Is there a horizontal asymptote? 0. We'll skip intercepts. I need to do this. Because you have the shortcut method. So look for x, your largest degree, which is x cubed. So on the top you have 0x cubed. On the bottom you have 1x cubed. So 0 over 1 is 0. Okay. So vertical asymptote, horizontal asymptote. At negative 3 and 3 you have maxes and mins. So, oh, gosh. Sorry, no, it's confusing to flip back and forth. So negative 3, you're going to have a min. 3, you're going to have a max. So the min is going to be negative 0.222. Ah, I keep going the wrong way. Negative 3, negative. And the max is going to be there. This one is kind of hard. If you plug in 0 for x, you can't do that. If you plug in when would y equals 0. So at square root of 3 and negative square root of 3, that's when you'd have 0 for y. So it's going to cross negative square root of 3, so 1.7. And so this is weird because it is crossing. So you're going to have something where it comes down and it goes like that, maybe? No. I got to think about when it's concave up, concave down. Yeah, that's right. Okay. Yeah, because it's concave down, so that's why it's curving right there. And then concave up. And then what's the rest of it do? Concave down and then up. So it's going to come like this. And then it's going to go up like that. Do you guys see what I mean by concave down, concave up? So there's some kind of point of inflection right here, which we've found already. Okay, and then you'd have to label everything. Okay, so they take a little bit. Oh, I did it really fast, but basically I was finding the y-intercept, or the x-intercept, I mean, so I plugged in 0 for y. So on your original, that means 0 equals x squared minus 3. So I was solving that. So I got 3 equals x squared, so x equals plus or minus root 3, which is 1.73 something. Sorry, I went kind of fast.